Here we have a SAT math question. Okay, let's go with the information. The quadratic function a times x positive 5 the whole square negative d can be written as x negative 9.5 times x positive c. If a is equal to 1, what is the value of d? Okay, the question clearly says the quadratic function over here and here, both of them are equal because this one only can be written as in this form. So we can equate both the quadratic functions, that is a times x positive 4.5 the whole square negative d equals to x negative 9.5 times x positive c. Okay, our aim is to find the value of d, and also there is an information that is a equals to 1. Okay, when I plug in a equals to 1, so it will become 1 times this stuff, the same will be getting like x positive 4.5 the whole square negative d. Let me write it over here. So I plug in a is equal to 1, and also I multiply this stuff by 1, and I'm getting the same stuff, negative d equals to x negative 9.5 times x positive c. Okay, now I can expand the square of the binomial over here using the algebraic identity, that is a positive b the whole square equals to a square positive 2ab positive b square. So whenever we square a binomial a positive b, it can be written in the form a square positive 2ab positive b square. It's an expansion. Like comparing this x positive 5 the whole square, a positive the whole square, at the place of a we have x, at the place of b we have 4.5. So in this expansion we have to replace a by x and b by 4.5. Okay, let me do it. So for a square we can write x square positive 2ab means for a we have to write x, for b we have to write 4.5. And positive b square means 4.5 square, and apart from that we have negative d, and also we can multiply the two binomials over here. For that we have to distribute x and x. I mean, I can use a FOIL method. FOIL method means like FOIL. So first I have to multiply the first term, then outer terms, inner terms, and last terms. So when I multiply the first terms x and x, I'm getting x square. When I multiply the outer terms x and c, I'm getting cx. When I multiply the inner terms, negative 9.5 and x, I'm getting negative 9.5 times x. And now I can multiply the last terms, negative 9.5 and positive c, I'm getting negative 9.5 c. Okay, now we get x square positive. When I multiply this 2 and 4.5, I'm getting 9. So I'm getting 9x positive. So when I take square for this 4.5, I'm getting 20.25 and negative d equals to x square. In these two terms, I find x as a common divisor. So x can be factored out from these two terms. So if I factor out x, then I'm getting c left in the first term and 9.5 left in the second term times x, negative 9.5 c. Okay, now, so here the quadratic expression are equal. So whenever two algebraic expressions are equal, then the coefficients of like terms must be equal. Okay, so since our aim is to find the value of d, I can equate the constant terms on the left side and right side because the two expressions are equal. So when I equate the constant term, what is the constant term on the left side? It's 20.25 negative d. So it must be equal to the constant term in the expression on the right side, that is negative 9.5 c. So why I equate only the constant terms? Because my aim is to get the value of d. So on the left side, the constant term contains a d. So that's why I just equate to the constant term. So constant terms. So in this expression, I mean in this equation, I have to solve for d, because according to the question, I have to find the value of d. If I want to get the value of d, I must be knowing the value of the unknown constant c. So how do you have to get the value of the unknown constant c? So for that, we can equate the coefficients of like terms, because on the right side, in the coefficient of x, we have c. So if we equate the coefficients of x, I'll be able to get the value of c. So the coefficient of x on the left side is 9, and the coefficient of x on the right side is c, negative 9.5. Okay, now what I need to do is I have to solve for c. For that, I have to add 9.5 to both sides. When I add 9.5 to both sides, this negative 9.5, positive 9.5 will cancel out. So when I add 9 and 9.5, I'm getting positive 8.5 equals to c. Okay, now I got the value of c, that is 18.5. Now what I can do is I can plug in this 18.5 for c over here and solve d. Okay, let me plug in, 1 second, let me write. Okay, on the right side, for this c, now I'm going to plug in 18.5. Okay, let me write the stuff on the left side as it is. That is 20.25 negative d equals to negative, when I multiply 9.5 and 18.5, I am getting, let me do it, I am getting 175.75. Okay, since my aim is to get the value of d, I have to get rid of this 20.25 over here. So I subtract 20.25 from both sides. Let me do it. When I do so, this positive 20.25, negative 20.25 will cancel. I'm just getting negative d is equal to On the right side, I'm getting negative 196. Okay, so here my aim is to get the value of d, but here we have negative sign. To get the negative sign, we have to multiply both sides by -1. So when I multiply this negative d by -1, it will become positive d. When I multiply this negative 196 by -1, I'm getting positive 196. I got the value of d. The value of d is 196.